Good. How are you?
Good.
Good.
So how's the algebra coming?
Uh, it's going all right. Uh,
You coming down to
I
finals? You must be having finals in a couple weeks here.
I think it's in a few weeks here. This is actually I have our last test tomorrow
Okay?
before the final.
For the final. So this is the last new material.
Last new material. So it's you know, on our last test, I it had to do with like complex fractions and all that stuff.
Okay?
And I thought that I knew it, and I studied, and I got all the homework 100% right, and I went into that test, and I got a C on that.
Okay?
So that
Complex
brought my grade.
fractions. Go ahead and give me an example.
Well, what I would actually like to focus on this time is it has a lot to do with like radicals and rational functions,
Okay?
graphing radical equations, graphing functions, and all that stuff. Because if I get a B plus or above on this test I'm taking tomorrow,
Yeah.
then I will be headed into the final with an A minus.
Okay.
But if I don't get that, then I'll be headed into the final with a B plus.
Okay.
So
So it's like being in the finals of a tennis match. You got a lot of pressure.
exactly, a lot of pressure. So I need to focus. The good part is that the teacher's going to let us use our notes.
Okay.
So
Okay. We don't have
that's
to memorize
helpful.
stuff. We just have to know how to do problems given certain things.
Right.
All right. So what kind of problems are you unable to do?
I am struggling on the ones where it involves like cube roots and fourth roots. For example,
Okay.
here's one from the homework.
Okay.
The cube root or the fourth root of 32, a to the sixth, b to the second, c to the 12th.
Okay. Take each one of these variables separately.
Okay.
So, in other words, I could, if I chose to, write this as the fourth root of 32 times the fourth root of a to the sixth times the fourth root of b squared times the fourth root of c to the 12th. Okay? Let's handle each
Okay.
one different, separate. What's the fourth root of 32? What number, when multiplied by itself 4 times, is equal to 32?
See, is there like a trick to this, or do you kind of just have to
There really,
go
there
about it?
really is kind of a trick to it. You have to know, first of all, know your minimal numbers. In other words, 2 squared is 4, 2
Uh-huh.
cubed is 8, 2 to the fourth is 16.
Okay.
So the fourth root of 16 is 2. So I can break
Okay.
this thing up into the fourth root of 16 times the fourth root of 2. And that's an important thing to understand, that you can always break these things up into the product. The advantage of doing that is that I can now replace the fourth root of 16 with the number 2. So the fourth
Okay.
root of 32 is 2 fourth roots of 2.
Okay.
Okay, you see how I did that?
Yeah.
Okay, so that's the number part. Now, let's talk about the fourth root of a to the sixth. First of all, what would the fourth root of a to the fourth be?
Um, that would be A.
Okay, what would the fourth root of a to the eighth be? So, knowing that, the fourth root of a to the sixth is the fourth root of a to the fourth times the fourth root of a squared. In other words, I'm going to break up my a to the sixth into an even multiple of 4 times whatever's left over. Because I can now replace that with a.
So then we end up having 1a with
I'll
2 left
write
over.
them in order with the fourth root of a squared. Now when we get done, we're going to put all these fourth roots back under the radical sign.
Okay.
But what the fourth root of b squared is just the fourth root of b squared. It's actually I can change that to the square root of b. It's kind of important to understand also that this can be, that's the same as that, which is the same as this, which is the same as the square root of b. Okay? So anything that has the fourth root of something squared, we can turn that into the square root if we want to. I'm not sure exactly. Let's get to the final answer and we'll see. What's the fourth root of c to the 12th?
That's going to be c cubed.
Yeah. So there's our answer, and we can express it in a number of ways. I could take everything that's outside the radical sign and put it together. So we have 2ac cubed, which covers that, that, and that. Everything else is under the fourth root sign. So I can put everything else, if I choose to, like that. Now, whether or not I want to convert this and this to square root or not, I'm not sure. I can't really convert the fourth root of 2 to anything, so I'm going to need a fourth root sign. I guess what I could do if I wanted to would be this times the square root of ab. You see where those are the same things?
Yeah.
And maybe this is the answer the teacher would prefer. I don't know. This is kind of an odd question. I haven't really come across something like this, so I'm not sure what the standard format for an answer is. Whether it's to leave it all with just one radical sign, or is it to separate it into 2 different radical signs. But
I think in class we've been just keeping it all in one.
Yeah, that's what I would kind of guess. That this would be the answer. Yeah. The key is to just separate it term by term. In other words, being able to take this expression and turn it into the fourth root of 32 times the fourth root of a to the 6th times the fourth root of b squared times the fourth root of c to the 12th. And then you can simplify each of those 4 terms and then recombine it back under the radical sign.
Got it.
Okay.
So, do you think that it would be, because when we're in class, the teacher, she's always talking about, like, you know, what's the largest, you know, fourth root that can go into this number, and I have no idea what any of those are. So do you think it'd be a good thing to, like, Google those and then, like, write them down on my note sheet? Might make it easier on the test.
First of all, any test you get, the answer to this is going to be one of the small numbers. It's not going to be 17. It's not going to be 9. It's going to be 1, 2, or 3. Okay? So knowing that, when I first looked at this, I questioned, is that 2 to the 4th? I knew it should be 2 to the 4th or 2 to the 5th. It's actually 2 to the 5th. 32 is 2 to the 5th. So, yeah, if you wanted to memorize something, this thing will last you a long time. In other words, this will be knowledge that you won't waste memorizing this.
Right.
This is the way computers evolve. When 40 years ago, when they first invented the first computer, you started out with 8 kilobytes. The next thing up was 16 kilobytes. The next thing up was 32, 64, 128K. And then they went to megabytes. Doesn't matter. It still goes in powers of 2. So a lot of real world applications have powers of 2. So it's worth, I would say it's almost worth memorizing 2 to any power, single digit power. Up,
Okay.
and my memory tells me that 2 to the 10th is approximately 1,000, but it's actually 1,024. If you keep doubling these, you get 64, 128, 256, 512, 1,024. By the time you get to 2 to the 10th, you're at approximately 1,000.
Okay.
Okay. And why is that important? Well, if I said to you, what are the odds of flipping a heads on a coin 10 consecutive times? It would be 1,000 to 1. Because in order to flip a coin 10 consecutive times, it's 2 to the 10th power. That would be the probabilities of it. So it's not that unlikely. I mean, 1,000 to 1 is pretty unlikely, but even still, most people would probably guess a much higher number than that. So when we have the 4th power of 32, knowing that it's 2 to the 5th that's equal to 32, but 2 to the 4th that's 16, so now I know to write that as this. Instead of the 4th power of 32, I'm going to do the 4th power of 16 times the 4th power of 2, knowing that I can replace that with the number 2. So that would be 2 4th power of 2.
2. Okay.
I mean, that's a pretty tough problem, actually. I'm
Yeah, those ones are. That was probably like the trickiest thing that I had.
Well, let's take something else. Let me give you another one.
All right.
So what number are we talking about here? Are we talking about the number 1, 2, 3, 4?
3.
Yes. So 3 to the 1 equals 3. 3 squared equals 9. 3 cubed equals 27. 3 to the 4th equals 81. Well, we're looking for the cube root of 81. So how would I factor 81 into two products?
You would. Would you get? So we know that it's 3 to the 4th.
Right. But which one of these converts to a whole number? 3 to the 3rd. In other words, the fact that 3 to the 4th is equal to 81 doesn't help us. What we know is the cube root of 27 is a whole number. That is 3. Well, 27 times 3 is 81. So I'm going to separate my cube root of 81 into a cube root of 27 times a cube root of 3. You see why I do that?
Yes.
Because now I can replace this with the number 3. So the cube root of 81 is actually 3 cube roots of 3. That's the same as this.
Okay.
And
So you have to look for
yeah,
a factor that can be simplified.
well, you have to look for perfect cube numbers.
Perfect cubes. Okay.
Or if it's fourth root of something, then you have to look for perfect fourths. But like I said,
Okay.
your answer is always going to lie in the numbers 2 and 3 or 4 at the worst case. They're
Okay.
never going to give you a problem that 7 is the, that where you
Yeah,
have to
that'd be
know
a big
7
number.
cubed. They don't go up that high. You're only going to be dealing with numbers that are 2 or 3. So if you have 2 to the 5th memorized, and 3 to the 4th memorized up through this, that will probably handle you in most any problem you get.
Right.
What is the cube root of 162?
162.
So separate that in a manner which allows you to pull a whole number out.
81 goes in twice.
Okay?
So we're gonna
But
have
81 is 3 to the 4th power, which doesn't do us any good. We want this number. In other words, we want to look for whatever 3 to the 3rd power is.
Okay.
So I could separate this into the cube root of 27 times what? What's 162 divided by 27?
That is 6.
Right. And this we know to be 3. So that would be 3 cube roots of 6. So the key numbers to memorize when you're talking cube roots are just this one right here. We want to find a factor 27 in this number. If it was the 4th root, I'd be looking for a factor of 81 because 3 to the 4th is 81.
Okay.
In other words, let's make this problem the 4th root. Okay, well now I would say that that is the 4th root of 81 times the 4th root of 2. And the 4th root of 81 is 3.
Okay.
Okay.
Yeah, this makes more sense
Well,
now.
I'm glad. I don't feel like I'm explaining it terrifically well, but
No, but you're doing a fine
okay.
job.
Whatever this number is, that's what we want to find here.
Okay.
Okay? It's not so much that we're looking for 81 as much as if we're talking the cube root of 162, then we're looking for a 27, not an 81 as a factor. If we're looking for the 4th root of 162, then we're looking for 81 as a factor because of that 4 right there.
Okay.
Okay?
Here. This is the other concept that kind of tricked me up a little bit.
Okay.
Let's see here. Let me find a more difficult one. Alright, so we have the square root of 3x plus 13, and then on the outside of that there's a negative 5.
As a coefficient or as an exponent?
Not as I think it's as a coefficient, but in this problem there's no parentheses. I don't know if that affects it at all.
Well, if there's no parentheses, where is the negative 5?
it is after the 13, but it's separate from the radical.
Like that?
It looks like that, but without the parentheses. I'm not sure if that makes any difference.
Well,
And
it
then
wouldn't make sense if I wrote it like that. Unless it's just minus 5. In other words, the square root of 3x plus 13 minus 5. That makes sense.
Okay. And then all that is set equal to x.
Okay. Yeah, no, I get it now.
So is this starting to make more sense
Yes,
now?
absolutely.
All right.
In other words, you have a radical equation.
Yeah.
And the way to solve radical equations are to isolate that and then square both sides. So isolate that for me.
So we're going to add the 5 over.
All right.
So we're gonna
now square both sides. In other words, square that side, square that side. What's the left side become?
It just becomes 3x plus 13.
What's the right side become?
That becomes x squared plus 10x plus 25.
Good. Sounds like you've memorized that as opposed to actually foiling it out.
Yeah, now I know that when I see that they're the same, you can just add them for the middle term.
Right, right. In other words, the middle term is 2 times 5 times x. And it does speed it up a lot. It's well worth memorizing that.
Yeah,
So
it's really helpful.
how do we solve this problem?
So now it's going to end up being a quadratic.
Good.
So I would subtract the 3x and the 13 over.
That's usually the way to solve quadratics, is to set one side equal to 0. So we've got what? What's the rest of it?
X squared plus 7x plus 12 equal to 0.
Okay, now that can be factored.
So in the end it's just a factoring problem.
Yep. How does it?
So we're gonna have plus 4, x plus 4, and x plus 3.
Okay. So what are your solutions?
Our solutions are x minus 4 and x minus 3.
You got it.
And our teacher wants us to check for extraneous solutions.
Okay.
So to do that,
yeah, let me just make a comment about that. Whenever you have an equation that has a radical sign, or an absolute value sign, or logarithms, you have a high likelihood of having extraneous solutions. Okay, so when you see that, when you see that, or when you see this, those are the ones you definitely want to check for extraneous solutions. Okay, so the way we check that is we plug in each one and see if it makes sense. Well, if I plug in minus 4, what is inside this radical sign?
Inside that that's going to end up being plus 1.
Okay, 1 minus 5 is minus 4. That was a solution. So minus 4 is a valid solution.
So that one works.
How about minus 3? What's inside the radical sign?
We're going to get negative 9 plus 13. So 4 minus 5 is negative 1.
Well, now hold on. It's the square root of 4.
Oh, square root. Oh, so 2.
Minus 5 is negative 3.
3. So that checks out.
Yeah, that works also. Not all equations that have radical signs are going to give you an extraneous solution, but a lot of them will. So whenever you're solving one, you definitely want to check the solutions. As opposed to if I just had a quadratic like this, I'm going to come up with two solutions. It's not so important that I check them because I don't see anything in that that lends itself to extraneous solutions. There's no absolute value sign, there's no radical sign, there's no logarithms. So a problem like this wouldn't be as vital to check for extraneous solutions. You might be able to come up with a polynomial equation that has extraneous solutions, but I can't think of one.
Yeah, I'm not sure.
Yeah, but anytime you have the other things, there's a high likelihood of there being one.
Okay.
You got time for another problem if you have it?
All right. Let's see here. Could we go for, so here's one. We have 1 equals the square root of 3 plus x, and then separate from that radical, there's a minus another radical x.
Okay.
Perfect.
When you have two radicals in an equation, you have to try to eliminate both of them. But sometimes it's hard. This is a hard problem. What's the first logical step?
Do we try to
separate the radical?
Isolate?
Yeah, one radical on one side, the other on the other.
Okay.
So if I add square root of x, I get this on the left side. Now I can square both sides. But squaring both sides is not going to eliminate all the radicals, but it will eliminate one radical. You have to do this in stages. Okay, so in other words, I've isolated a radical, and now square both sides. What do you get?
You're going to get 1 plus 2 radical x plus x.
Good.
And then 3 plus x.
Notice I now only have one radical sign in my equation. So if I can isolate that, I can square both sides again. That's the way you do these. Okay, well, the first thing I can see about this is I can cancel these x's, right?
Yeah.
And subtract x from both sides, which leaves that. Now let's subtract 1 from both sides. So I have 2 radical x equals 2. Now divide both sides by 2. Now square both sides.
So we divide both sides. So we have radical x equals 1. So then x is just going to equal 1.
Yeah, now let's check that solution. So does x equal 1 work here? Well, is 1 equal to the square root of 4 minus the square root of 1? And yes, it does.
Yep, it works out.
Yeah, this is as hard as it's going to get with radicals. I'm actually surprised that you're getting that in your class. I would have expected maybe from honors algebra, but not from regular algebra, or algebra 2.
Yeah, this was the teacher always gives us like the last worksheet is always like the hardest one, and this was the last problem on the last worksheet.
So. Trust me, I dread Aprils and Mays because I always know that that's where the hardest material is coming from all of my students. Yeah. Whatever the last new material you learn is, it's always
going to be the hardest.
Before they start reviewing old stuff.
Yeah, our teacher handed out a review packet from the entire year that's 160 some
Oh
problems.
my goodness.
Yeah.
Wow. How many
So
pages?
it's it's a very large packet.
Okay.
It's got to be like 12 pages, maybe even a little bit
But
more.
probably most of them you could verbalize, right?
Yeah, I think we can.
Yeah.
I mean,
You want
we'll be having a lot of meetings.
Okay, well, good. We can go over those. You don't need to send pictures of every page to me. The only ones you would want to send to me in advance are problems that are difficult to verbalize. In other words, if they give you a graph and want
Uh-huh.
you to come up with the equation of that graph, that's not easily verbalized.
Okay.
So, but I'm guessing that 90% of the review packet you could verbalize.
I bet
Maybe you
so.
might have to take pictures of one or two of the pages and send it to me so that I could bring it up on my screen.
And do I just send those to your phone number?
No, send them to my email. Let me give you the best email to send them to. Hold on.
All right.
I'll write it on here. You may have it already on file.
I probably do somewhere, but it doesn't hurt.
I think I gave your mom my digital math tutor, and that's not the best email to send. This is the
All
better one.
right.
If you send it to my digital math tutor, it gets relayed, and sometimes I don't get it for 10 minutes after the student sends it. But if you send it to this email, I get it right away, pretty much, within a minute.
Awesome.
All right.
All right. Well, thank you very much, and I'll let you know how it goes.
Well, oh, good. Okay. Well, good luck.
Thanks.
All right.
See
All
ya.
right, Casey. Bye-bye.